My dear students, I welcome all of you for today's session on system modeling and simulation. In this session, we will discuss the rest of the part of calibration and validation of models. In previous session, okay, we had a discussion about calibration and validation of models. And I taught you there are three methods of validating a model. Clear? They are face validity, validation of model assumptions, and validating input-output transformations. Okay, those two methods, the first two methods, face validity and validation of model assumptions, have been discussed in previous session. And in this session, I'm going to discuss with you the third method, that is validating input-output transformation. Got it? So, hope everyone remember what actually calibration and validation, right? So, let me repeat once again. Okay, let me state the definition. Okay, so what actually validation means? Validation means the overall process of comparing the model that is built. Okay, there's a process of comparing the model that is built. Okay, and along with its behavior, means along with the behavior of the model, to the real system and its behavior. Got it? So validation means comparing model and its behavior to real system and its behavior. Got it? So what is calibration? Calibration is nothing but iterative process of comparing model to real system. Okay, I said right, calibration is nothing but iteration. Okay, here I say it's an iterative process of comparing model to the real system. You should remember the previous diagram, okay, what I shown in previous session, okay, regarding iterative process of calibrating a model. Okay, so when I compare model with real system, I find deficiency in the model. Got it? So what I need to make some adjustments, minor changes. Then I'll compare the revised model with real system. If again deficiency, I need to revise the model. So this process repeats until I find model to be valid. Got it? So what is calibration? Is nothing but iterative process of comparing model to the real system, making adjustments to the model, comparing revised model to reality, making adjustments, comparing again, and so on. Clear? So, then after introducing calibration model, we had a discussion of we have come to know about three methods suggested by Naylor and Finger. Of those three methods, we had a discussion about face validity. We had a discussion about validation of model assumptions. Clear? So in face validity, you know, right? One, I can take that to an expert. The expert will look at model and will judge. Clear? Clear with that? So face value, there are the two types of test. Even you should remember there are two types of test I have discussed with you. One is subjective test and objective test. Subjective test, taking the model to an expert in simulation language. He will judge whether the model seems to be almost valid or need to be improved. Got it? So in objective test, what I said, we are going to give some data as an input. It's going to produce a behavior or some output that need to be compared with real system. Got it? So validation model assumptions, there were two assumptions, structural assumptions and data assumptions. Remember, face validity is the one method. Got it? Then and model assumptions, so two things, structural assumptions, data assumption. Structural assumption means how is the structure of the system. Means suppose in a bank there are two or more tellers with a separate queue for each tellers. Got it? And how the customer will serve first come first serve basis. If one of the line is moving very slowly and the other line is moving very fast, a user from one line may jump to the other line which is moving very fast. This is a structure. Got it? So we need to consider this. And data assumptions means probability. For example, how fast the input may vary. Got it? I mean, what may be the inter arrival time between consecutive customers? Got it? And what may be the service time for each transactions? Clear? So in data assumptions, it's related to statistics. Mean how frequently customers will be arriving. Clear? And what may be the service time for each customers? This we need to consider into an account. Now, coming to third method, validating input-output transformation. Okay. So, here, this is the agenda of this session. Okay. Validating input-output transformation. What actually input-output here? Okay. You should not get confused whether the same thing what I stated in previous two methods. With respect to objective test, something I said, I'll give an input, I'll observe the output. Then that I'm going to compare with the real system. Clear? In model assumption data with respect to data assumptions, I should not get confused. Okay. Validating input-output transformations, something else. I'll tell you about that. And this again, there are two subsessions, subtopics. One is input validation, input-output validation can be done using two ways. Using historical input data. I mean, historical means history, previous, earlier input data, the past input data, past real data that I'm going to collect from the managers of the bank. Okay, making use of past input data, I'm going to validate the model. Then using a Turing test. Okay, I think you're familiar, right? You had a machine learning subject in your previous semester, I hope. There you have heard something Turing machine. Got it? Turing. Okay, Turing machine, some fake machine pretending to be a original one. Got it? This is very interesting topic. Okay, Turing test that I'll tell you later. Okay, at present, just remember, just think about Turing machine. Okay, machine learning subject. Okay, now we'll come to the first agenda of this session, validating input-output transformation. See, the ultimate test of a model, okay, is the one only that the test of a model, okay, can be done using an objective test. Okay, what I said objective test, the objective test, what it does. Okay, to test the model, I said the subjective and objective. Subjective, we are taking to an expert. He is going to judge about the model. So what about objective test? Okay, it's a precise. Okay, objective test, what it does is the models in this, the model's ability, we can come to know in objective test. I repeat, in objective test, okay, we can come to know the model's ability to predict the future behavior of the real system. Okay, when the model input data match the real inputs. I mean to say, through objective test, okay, I mean future means maybe a day or a month later, okay, uh, some how the system is going to behave, okay, we can predict through model. One, that model is subjected to objective test. Got it? So through objective test, okay, through objective test, I can model, as a model will have an ability to predict future behavior of the system. Okay, when a system is given the same input. Got it? So, in some case, okay, let me say, right? Let me give you an example. Whether the number of customers that may arrive to bank is always same, or whether the number of customers arrive at early morning is same as the closing time. Okay, whether the number of customers arriving in regular days is same as a peak day, I mean to say month end or month beginning, it varies. Means we need to consider all these cases. Okay, means I said one of the input to bank is nothing but customers. Okay, how frequently the customers may arrive, whether that frequency of customer arrival increases or decreases, we can't predict. Got it? We can't. That is not question. That may vary. Even that I need to consider into account. So if the level of some input variables, okay, for the model, there are some variables, input variables. Let me say one variable that tells inter-arrival time between consecutive customers. Okay, suppose one customer arrive at 10:30, let me say. One customer arrive at time 10:30. And the inter-arrival time for next customer is 10 minutes, if I say. As if one customer arrived at 10:30. And for the next customer arrival, inter-arrival is 10 minutes. Means this inter-arrival time, what it means, the time between consecutive arrivals. Now the customer arrived at 10:30, right? So this next customer will arrive after 10 minutes. That is at 10:40. Because inter-arrival time, what I said here is 10 minutes. But this is not actually in real life, it may vary. So if the level of some input variables, that is arrival rate of customers, okay, to service facility, arrival rate of customers were to increase or decrease, okay, the model should predict what would happen in real system. I mean to say, in future, okay, in for the real system, the arrival rate of customers in real bank, okay, in a bank, the arrival rate of customers may increase or decrease, right? So in that case, how the bank is going to behave, right? That should be predicted by model. Okay, clear? So this is objective test will conclude this. Got it? So in other words, okay, not only, let me not consider only the arrival rate of customers. Okay, how the bank is organized internally. I mean, if there is only one teller, whether a separate line for gents, whether a separate line for ladies. Okay. So means I need to consider all the structure. Got it? So separate line for gents or separate line for ladies. Got it? And is the one or two tellers? Okay, separate queue for each tellers. This everything we need to consider into account when designing a model. Got it? So you're designing a model for some bank, you need to know about the structure of that bank, and that structure should be implemented in a model. Got it? And how that model is going to predict with respect to structure of a model that need to be analyzed. Okay, so the structure of model should be accurate. See, I repeat this. So the structure of model should be accurate enough for the model to make good predictions, not just for one input data, but for the range of input data. Means the structure of the model should be accurate. Means that the structure should not only work for one input data, it should work for any input data. Okay. So now coming to this method, okay. So in validating input-output transformation, model is viewed as input-output transformation. See, in this case, I'm viewing model as input-output transformation. Okay. So what it means? See here, model accept values of input parameters, right? Model accepts values of input parameters. Okay, and it's going to produce some output. But my concern is not on what the answer, what the result that is generated, what the answer that is generated. Rather than my concern is to measure the performance of an output. Clear? Means model accepts some values of input parameters, some input. And this input parameters, what I'll transform into output measures of performance. Means here I'm concerned with measuring performance of a system. I need what output that is generated. I need to evaluate the performance of output. Got it? So let me take your let me give an example. Okay. See, before giving an example, let me tell you. So usually what I said, okay, what happens? Got it right? I want my concern here is to measure the performance of the system. To be more precise, output measures of performance. So model is viewed as input output transformation. That means model accepts values of input parameters and transforms this input into output measures of performance. Okay, so I mean, see here, listen carefully. So tomorrow I don't know. I see. Can anyone predict the number of customers that may arrive to bank tomorrow? Or can anyone predict number of customers that may arrive to bank a week later? No one can predict, right? It's impractical. See, I mean, I want to see my model, okay, will predict the behavior of the system in future. See, I want my model to predict the behavior of the system in future. I mean, in future, input number of customers to the bank. I don't know how many customers may arrive to the bank tomorrow, right? Got it. I don't know how many customers may arrive to bank tomorrow. But simply I'm assuming some X customers will arrive to bank tomorrow. Okay. I just have assumed X customers will arrive to bank tomorrow. And that X as I'll give as an input to model. Okay. And then that model is going to generate some output. So But tomorrow, rather than X, some Y customers might have arrived. Got it? Y customers might have arrived. So what happens here? Model this it feels that model can't be validated accurately because of variation in model input and real input. So, but what we can do to judge if the model behaves accurately, sorry, to judge model predicts the behavior of the system accurately. Okay, model predicts behavior of the system in accurately in future too. See, my goal is I want to design a model. That model, okay, should reflect, should show the behavior of the system accurately in future too. So what I can do, because I don't have future inputs, so what I can do, I can consult the manager. I can consult the manager, and consulting the manager, I can get the past historical data. Means previous day, previous week, previous month. Okay, in a range of days, how many customers might have arrived to the bank? Got it? Previous data, historical data. Let me collect from the bank manager. And for those historical data, even the output data is available by them through the manager, right? Manager knows the performance of the bank in those days. Clear? So let me consult the manager, extract the previous historical data along with the performance of the bank those days. Now you have designed a model. Now you give one of the previous data set, one of the past data set, maybe a day before data set as an input to your model. Now your model is going to perform, transfer some output measure. Now check the output measure that is generated by model, okay, is reflected with the output measure generated by the real bank for the previous day. If it matches, then we can say almost model is being validated. So let me not just for one input data set. Now I've taken a data set for the about a week before also from the manager. Let me give that data a week before data, real data to the model. So model generates some output measures. Let me compare with this with the real output measure given by the bank for the past week. If it syncs, if it matches, then I mean to say my model shows the behavior of the system accurately for all historical data, right? My model shown the behavior of the system for all historical data accurately. It means model is able to predict the behavior of the system in future too. Got it? Clear, right? So I've been justified. I have justified that model has predicted accurately the behavior of the system for all past historical data. When my model has behaved, sorry, when my model has predicted, so when my model has predicted accurately the behavior of the system for the past historical data, it means the model also predicts the behavior of the system in future too. Got it? So let me say, and see, I said output measures of performance. Now I'll measure the performance of a system. This is a question. So, when you studied design and analysis of algorithms, you avoid two measures of performance: time efficiency and space efficiency, right? Similar to you. Say in banking system means when I'll give you explain this. because now you need to know what are those performance measures, right? So in bank, what are input? Customers. I mean, customers, I need to give inter-arrival time between the customers. Means input when I model a system, okay? The input is that I need to specify when each customer will arrive. And one more input is that what is the service time for each customers? I mean, the input to bank is inter-arrival time, when customers will arrive, service time of the customers. Also, the input is that I can tell the model that I assume there are two tellers, or assume there are three tellers, or assume there is only one server, one teller. So what output measure now? The measure is that I need to check, okay, server utilization. Means when I simulate for this, when I run the model with that input, I need to check, okay, if there are two or three tellers, two or three servers, how efficiently server is utilized. That is one measure, server utilization. Because if I have placed three servers, okay, but the majority of the time two servers are idle, means it is inefficiently utilized. So I can compromise with only one server. Got it? Means I can shift two server to some other bank. Got it? So the response here, one of the measure is to see server utilization, and other response is that how long customer delay. Because the longer the customer will wait, okay, what happens? If a customer feels that he is waiting for a long time, okay, he may migrate his account from that branch to some other branch. Got it? Got it? One is how efficiently server is utilized. The other is I need to look for customer delay, because I need to minimize customer delay. Clear? Because longer the customer waits, he will migrate his account from that branch to some other branch. Clear? This was about measures of performance. Okay. Now, this I need to study. Clear? So now almost one thing. These are the measures I need to evaluate. Okay. And one more. Now you're doing project, right? When you're doing project, what happens? You have asked to do literature survey in the first phase. So in your project report, when you form a report, you will say there is some existing system. Of course, almost all. If it is not a new idea, it's completely innovative one, means there's no existing system for that. It's a new system that you are being developing. But usually the most of the project what we are going to do is dependent, is an evolution of previous project. Means you are enhancing some previous project, right? Clear? So similarly, when I am developing a model, means already some earlier version of the model might exist. Getting my point? So when you're doing a project, you will write existing system. Means the model exists. I mean, the earlier versions exist. You are improving the model, right? So that mean what it means. Okay, if for the previous input, now I have built a model correctly. I have enhanced a model. Okay, now after enhancing the model, let me check this model work for one of the input of earlier version. If the model has worked successfully, means model, if the enhanced model even gives an output that matches the output of earlier version, means model is almost enhanced and it's validated. I mean, for enhanced model, you give an input which you are given for the earlier version, and conditions that earlier version should have been validated. Should have been validated. If earlier version is validated and that input, if you are given for this enhanced model and this enhanced model to predict to generate same output of as of earlier version, then we can say the new model is almost validated. Okay, so usually when enhancing the existing model, there are some changes, minor changes and major changes. Minor changes means let me say uh, minor changes of single numerical parameters such as speed of the machine. Means now the because of advances in technology, the speed of the machine might have been increased. Then arrival rate of customers, because the day-to-day customers are increasing because of competency, the customers account might increase in the bank. This might be a minor change. And other one more minor change is the statistical distribution. Okay, means how there will be something known as probability distribution that gives service time and interval times. How it's going to change? This may some minor changes may be there. Also, major changes. Major changes means the structure of the bank itself might change. The structure of the bank, I mean to say, queuing discipline. See, earlier there might be only one line, one queue. Got it? Let the structure of the bank might be changed so that a separate queue for ladies, separate queue for gents, separate queue for elderly persons. Separate queue for ladies, separate queue for gents, separate queue for elderly persons. Okay, this change in structures need to be considered when enhancing a model. Okay, also major changes involves I'm designing a new system. Okay, rather earlier it might be manually one, now it might be computerized. Earlier banking, right, when you go to and earlier if you ask your parents, and earlier their passbook used to be entered manually. Got it? But now it's entirely digital one. Just feed your passbook to a computer machine, it will enter, fill, and it will give. So when enhancing a model, there might be minor changes or maybe major changes. Okay. So minor changes might be increasing the speed of the machine or arrival rate of customers, distribution time of service and interval time. Major changes when I say structure of the bank, might increase. Sir, structure of the bank might change. Okay. Also, earlier might be manual one. It might now it need to be digitized. Now, using historical input data. Just now I told you, right? Historical data here, rather than using artificial input data. I mean, tomorrow I don't know, right? How many customer may arrive to bank? Am I knowing? I don't know how many customer may arrive to bank tomorrow. So I am just assuming. My assumption we call an artificial input data. So rather than checking for an artificial input data, means I'm saying artificial input data means inter-arrival time may be so and so, service times may be so and so. This is my assumption. Okay, and I'm observing the output and I'm predicting the behavior of the system. Okay, so rather than using assumption, artificial data, what I said, let me go to manager, collect the past, previous day, past week, past month data along with performance measures, and let me feed those input to my system, and let me compare the output generated with the output measures. Let me compare with the output measures given by a manager. If it matches, my model predicts behavior of the system for past historical data, right? It means it implies my model even predicts behavior of the system in future. Got it? So this is about historical input data. In brief, I told you because I repeated in previous slides. Okay, clear? Using the advantage of historical input data is that it is very precise. Okay, it validates behavior of the system in future. Now, using Turing test, it's very simple. Okay, see, you have learned machine learning language, right? So machine learning means what? Making machine to learn itself. We are making machine to learn itself through its experience. Okay. See, I mean to say, I'm a developer. Okay. There is one, according to me, let me think, a machine, a computer is a brilliant one. When I give correct input to computer, it gives expected output. Now I developed a machine. It's at initial stage. Now, initially, I kept in the room one real machine and the machine to be designed. When I give an input to machine, the computer, it gives correct output. When I give to that, it gives a wrong output. Later, it learns by itself. Okay. So the machine what I have designed is learning through experience. Next, when I give input, okay, when I give input and I'll ask anyone to answer, got it? Anyone to answer. Okay, even that machine in which was in design, it learned itself and it gives the correct answer. Now, even that machine gave me correct answer. Then, because those two machines, one is the computer and the machine in design stage, which are in separate room. Now I got a correct answer, but out I'll come to know that it is by computer or that machine design stage. If I'm not able to judge who has given the answer, means that machine in design stage is valid because it predicts exactly as a computer. Got it? Same here. See here, assume there are 5 reports of system performance. So 5 different days. Okay. There are 5 reports of system performance of 5 different days. Okay. And this is real 5 report by real system. And there are simulation output also produced 5 fake reports. Means I have 5 real reports and 5 fake reports. This 10 reports I'll place all of same format. Okay. And now it's been given to manager and engineer to verify. So the 10 reports are randomly shuffled and given to engineers. Now, what happens? Engineers and managers are not able to identify which reports are fake, which reports are genuine, original. So when they face a difficulty in identifying the fake and the genuine report, it means model has generated report correctly. So model behavior is predicted accurately in future. This is Turing test. This is about the current session. Thank you for listening.